All right, let's actually get in and do some probability problems. So we're going to start with some basic probability stuff and then talk about some more complicated rules for addition, multiplication, conditional probability. Again, that's another good one. So we're going to start with the same little example. We still have 10 jelly beans. 1 blue, 2 purple, 3 green, and 4 red. And from this set of 10 jelly beans, we're going to draw a single jelly bean. Now, we don't know for certain which color we're going to draw, but we know that it's going to be one of those 4 colors, and we know the chances of each event. How do we know the chances? How do we know the probabilities? Finding the probability of the events, combinatorics, aka counting. All right, so we're just going to do a little counting in this example. Count how many favorable outcomes there are and divide it by the total. Thumbs up is favorable. I don't know what total is. All right. We're going to divide it by the total. So what's the probability of a green jelly bean? That's just going to be the number of green divided by the total. Let's maybe not. N's not. We could use N. It's fine. But I'm just going to write total. So there are 3 greens. There are 10 totals. 3/10. Or 30%. And again, I'm okay with either format here. Fractions, as long as they're reduced, simplified fractions, or percents. I'm personally a percentage guy, but I'll take either. What's the probability of drawing a purple? Again, it's just going to be what's the number of purple divided by the total. Well, there are 2 purples. There are 10 totals. This is not our final answer because this is not reduced. So it's going to be 1/5 or 20%. What's the probability of a blue or a red jelly bean? So same logic. How many blue or red jelly beans are there? And how many are there total? Well, there's 1 blue and 5 red. So there are 5 favorable outcomes, right? There are 5 jelly beans that are either blue or red. So again, this simplifies to 1/2 or 50%. We're counting all the ones that are either blue or red. So we're going to move on to this screen. Again, let's just copy this down, right? There's 1 blue. There's 4 red. There's 2 purple and 3 greens. Do not have room to write this. Now I just am not going to have to scroll back and forth. So what's the probability of drawing a jelly bean that is purple and blue? Well, how many purple and blue jelly beans? What's a single jelly bean that's purple and blue? How many of those do we have? We don't have any. Right? All of our jelly beans are a single color. We don't have any purple and blue. That's going to be 0 out of 10 or 0%. This time, don't write 0 as your final answer. 0 out of 10, it's 0% or 0. That's our final answer. There's no probability of getting a jelly bean that's purple and blue because there's none in the bag. All right. There are no multicolored jelly beans here. What's the probability of drawing a jelly bean that is not green? Well, how many things are not green? 1 plus 2 plus 4. That's how many jelly beans are not green. So 1 plus 2 plus 4, not green jelly beans. 10 jelly beans total. That's going to be 7 out of 10 or 70%. Now, we almost never solve problem E like we just solved it. This is one of those little tricks that math professors like to play on you sometimes. We do a problem the bad way, and then we say, look at this much, much better way. And that's what we're going to do afterwards, right here. We're going to talk about compliments with an E, not compliment. I'm not saying jelly bean, you look good. I'm saying the other one. So if we want to find the probability of an event A, so in this case, the event A would be maybe a green jelly bean, right? Could do this. Then the probability of a complement, and this is pronounced a complement, is just 100% minus the probability of A, right? This makes sense. What's the probability of getting something that's not green? Just 1 minus the probability of getting something that is green, and vice versa, okay? So if we wanted to, right, in this one, another way of doing this would just be, what's the probability of getting it green, and subtract that from 1. 1 minus, there are 3 green ones out of 10, is also 70%. Okay? 1 minus the probability of green. P of green, probability of green jelly bean. All right, so last example. If there's a bag of 3,895 jelly beans, is that a really big bag? It sounds like a lot of jelly beans. This is a big bag, right? Let me know if this isn't a big bag. I don't know. With a variety of colors, and we know that 825 of those jelly beans are purple. So what's the probability of drawing a jelly bean that's not purple? Okay, so if we use this, right, let's put this in terms of these letters, right? So A is the event of getting a purple one. A complement is the event of not getting a purple. So the probability of drawing something that's not purple could be written like this. It's going to be 1 minus the probability of drawing something that is purple. Just 1 minus, well, 825 are purple out of 3,895 total. And you can type this into a calculator. You can do it in steps. You can do it all at once. I don't have much of a preference, but 1 minus 825 divided by I can't remember that. 1 minus 825 divided by 3895. Google is my favorite calculator. We're going to get about 78.82%. Is the probability of getting a jelly bean that's not purple. And likewise, there's a 21.18% chance of getting one that is purple, right? That's what this one right here was, 21.18%, if I can do my math in my head correctly. And if I don't, just pretend I did to get the point across, okay? And that is complements. That is basic probability. In future videos, we will do less basic, but still not anything super crazy, but less basic probability.